Okay, hi Addy. Welcome to lesson number 92. Look at the title on this lesson. It looks humongous. We're going to talk about a lot of things today. Expanded notation with exponents. So the exponent part I think is the trickiest part of this lesson, but not for you because you are a math whiz. You're going to get this right away. Then we're going to talk about order of operations with exponents and the powers, I should have said powers of fractions, meaning like 1/2 to the power of 2 or to the power of 3, something like that, right? So it's going to be awesome. All right, here we go. I've decided to become a math teacher, Addy, but I'm only going to teach subtraction. I just want to make a difference. Get it? Did you get it? That was a good one. All right, guess what? We are going to start with your warm-up, your facts practice. Get out your test L, liquid measurements. Make sure you have a pencil, and on your mark, get set, go.
Shadow, go.
Should we let him?
Yep.
Don't kill it. Oh, sorry, Addy. Sorry. Oh my heck. Did you hear me screaming? Oh my heck, there was a cat in the backyard with all the chickens. That was so scary. And anyway, we let the dog out, so hopefully, I think the cat ran away. Oh, that was scary. Okay, now we're gonna jump into the rest of mental math. Here we go. That was quite the interruption in your video. Sorry about that. It was an emergency broadcast system. First, we're gonna count up and down by 25s between negative 150 and positive 150. Okay, here we go. Let's start with negative 150. And we're going to look at a lot of baby pictures today. I thought that would be fun since you're going to be an aunt soon, okay? So negative 150, negative 125, negative 100, negative 75, negative 50, negative 25, 0, 25, 50, 75, 100, 125, 150, and it says count up and down, so we got to go back down. 150, it looks like 80, but it was 50. 125, 100, 75, 50, 25, 0, negative 25, negative 50, negative 75, negative 100, negative 125, negative 150. We did it. That's Shadow drinking in the background, all that slurping. He is very noisy. Alrighty. Ready? Let's do the rest of mental math. What is 30 times 50? What I would do is do 3 times 5 and then add 2 zeros. Perfect. Easy peasy. What's 486 plus 50? What is 50% of 24? Now, we haven't done these before, but you're going to think of this as half. So what is half of 24? D. What is $20 minus $14.75? This cute baby. Okay, what is 100 times 125? We're going to be moving that decimal, aren't we? That's got to be a dizzy baby right there, but he's doing it, so he must like it. F, what is 600 divided by 30? I would cancel out a couple of those zeros and just do 60 divided by 3. You'll get the same answer. Okay, this is a long one. Ready? We're going to start with a number square root of 36. So start with that, square root of 36. Add 4, multiply by 3, add 2, divide by 4. Now add 1, and what is the square root of that number? Cool. All right, Houston, we have a problem here. We need you to solve the problem, Aunt Addy, so here we go. Now, George's average grade on 4 tests is 88%. What does that mean? Well, it means he's already taken 4 tests. 1, 2, 3, 4. We don't know his scores, but we know that they averaged to 88%. What grade does he need on his 5th test? Okay, so there's going to be another test right here, to have a 5-test average of 90%. So he wants a 90 overall. How can he do it? What can he get? So they want to know this here? What grade does he need to get on that 5th test? All right, I'm gonna let you solve that one, so you pause it right there. Look at cute Lucy, and what was her baby's name? Didn't she name it after her husband? So Ricky? I can't remember. All right, here we go. New concepts. We are gonna go over expanded notation with exponents. So remember back to lesson 32, that was like 60 lessons ago. We started writing whole numbers in expanded notation. So the way we do it, if you're just writing whole numbers in expanded notation, you take a number like this, 365, and what we would do is take that 3 times 100, okay, so that would make 300. We're gonna put that in parentheses, then we're gonna add to it this 6 times 10, okay, and I'm running out of space, so I'm gonna make this smaller, okay, and then we're gonna add to it this 5, and it's just 5, it's just 5 times 1. Okay, so cool, that's how we do it, expanded notation. You take each number and you basically write what place it is in. 3 is in the hundreds place, 6 is in the tens place, 5 is in the ones place. And if you multiply those out and add them together, you will get 365. Cool, huh? All right, there's another way you can write it in expanded notation, okay? Instead of this, you can use exponents. So let's try that. Okay, so you could do, instead of 3 times 100, 3 times 10 to the 2. Now, 10 to the 2 basically tells you how many zeros there are going to be in the final number. There's going to be 2 zeros, but it's, you know, you remember how to do this. 10 to the 2 actually means 10 times 10. And 10 times 10 is 100. So it's basically saying 3 times 10 times 10, but in a shorter way. Okay, so it's 10 to the 2. Then we're gonna add to that 6 times 10 to the 1. Why is it 10 to the 1? Anytime you write 10 to the 1, it's not 10 times 10, it's just a 10. You basically can eliminate the 1 every time there's an exponent. Like there's actually an exponent on this one, this one up here. It's just, we usually don't write it. But 10 to the 1 means there's just 1 0. That just means 10. It's in the tens place. Okay, and then we write 5 times 10 because everything is times 10. But there's zero zeros, so we're gonna put a 0. 5 times 10 to the 0. 10 to the 0 means we don't even have a 10. We have 0 tens. We just have a 1. So 10 to the 0 always means 1. 10 to the 0 is the same as 1 because we don't even have 10. We have 0 tens. So let's look at this table. Notice how in the table, the first thing I want you to notice is that we start at 10 to the 0. That's the ones place. And then this exponent goes up by 1. 1, 2, 3, 4, 5. And it keeps going all the way to 10 to the 14. The thing that's nice about this is that it tells you how many zeros are there. 10 to the 0 is just a 1, and this is the ones place. These are the ones, and so it's ones, tens, hundreds in the ones place. There's also ones, tens, hundreds in the thousands place. There's 1, 10, hundreds in the millions place. Why? Because you could have 1 million or you could have 10 million. What would 10 million look like? Well, it would have 7 zeros. 10 million looks like this. If you had $10 million, that's how you would write it. There are 7 zeros. 1, 2, 3, 4, 5, 6, 7. It's 10 to the 7. Okay? Like, it's basically 1 times 10 to the 7th. because there's a 1 here. If it was 5 times 10 to the 7th, there would be a 5 here. Okay? So then we keep going up. This is the billions place. 1 billion, 10 billion, 100 billion. 100 billion has that many zeros. If you look at how much our government is spending right now, it's in the trillions. How many zeros is that? A lot. So if you spend $3 trillion, you have 3 followed by 12 zeros. That's a lot. Okay, this is 10 trillion, this is 100 trillion. Okay, and that's as far as we're gonna go. Okay, so cool. Hopefully you understand it, but if not, it's okay. We're gonna do some examples and you'll get it, okay? Example 1, and here is a picture of Einstein, because he was the one that kind of, actually, was he the one that figured out that light, the speed of light is basically constant? I know he was one of the important ones that used the constant speed of light in his theories. Okay, what is the speed of light? Did you know it goes the same speed everywhere it goes? It doesn't speed up, it doesn't slow down. It instantly goes this speed as soon as it leaves a light bulb and goes into your eyeball. It's really fast. The speed of light is 186,000 miles per second. And then it says, write 186,000 in expanded notation using exponents. Okay, so let's do it. I'm gonna move this picture out of the way because I feel like we're gonna need the space. First, I'm just gonna write the number 186,000. The units are miles per second. Okay, cool. So let's start at the beginning. We are going to start with this 1. If we start with the 1, it's going to be 1 times 10 to the what? Now let's just pause for a moment here. What place value is this in? If all of these were zeros after it, it would be 100,000. Let's look back at our table. We're in the thousands, and it's the 100,000s, so it's going to be 10 to the 5th. Okay, so it's going to be 1 times 10 to the 5th. Okay, and then we put that in parentheses, and we're going to add to it the next number. The next number is this 8. What place value is this in? This is also in the thousands, but it's only 10,000. I know that that's going to be 1 less than this number. And I also know that I can count the number of zeros that would be after it. 1, 2, 3, 4. So it's going to be 1 times 10 to the 4. Whoops, I made that parentheses too little. Okay. All right, so 1 times 10 to the 4, let me just pause here and show you what that would look like. 1 with 4 zeros after it. And I know that that's right because this is the place value that that is in. Cool, huh? Okay. Now, the next number is 6. So it's going to be 6 times 10 to the what? Okay, this is the important part. This is how you're going to get the questions either right or wrong. Now, interesting, look how these are only 1 step away from each other, 1 place value away from each other, and these exponents are going down by 1 value, 5, 4, so this one is going to be 3. Okay, cool, and then that's all we have to do because we don't have to do all of these zeros. They're included in these exponents. They're included when you say times 10 to the 3, then you have to add all those zeros. So that's what you would add, right? Cool. This would basically be 100,000 plus, oh, I messed up here. I messed up here. This should be 8. I'm glad I saw that because this is this number. So instead of writing a 1, it should be the number that it is. So that would be 80,000 plus 6,000. Cool. Alrighty. And how do you do the order of operations? Now, the first thing that we're going to do anytime we do order of operations is we're going to do the parentheses. Start with the parentheses, then simplify the powers. Powers means like 3 to the 4th power. So exponents like that. Exponents, powers, and roots. Then we're going to multiply and divide left to right, and then we're going to add and subtract from left to right. How do you remember that? Please excuse my dear Aunt Sally. P is for the parentheses. E is for the exponents. They didn't use the word powers, but it's exponents and roots. And I'm going to write exponents and roots. Okay, and then my dear means multiplication and division. Aunt Sally means addition or subtraction. Cool. Please excuse my dear Aunt Sally. Alrighty, let's do example 2. Example 2 is basically this big, long problem, but you have to figure out what to do first using please excuse my dear Aunt Sally, or the order of operations, excuse me. Okay, so here we go. The first thing, please excuse my dear Aunt Sally, is parentheses. So we're going to simplify this part first. Okay, so I'm going to rewrite the problem and do 5 minus 16 divided by square root 16 plus 3 squared times 2. Okay, please excuse. The next step is to do exponents and roots. Okay, so we're going to do exponents, which is this one, and we're going to do roots, which is this one. And you do them from left to right. So it's going to be 5 minus 16 divided by, what's the square root of 16? We're going to change that to 4. Plus, what is 3 squared? We're going to change that to 9. And then we're going to multiply by 2. Okay, now we're going to do, please excuse my dear, so multiply and divide. Okay, so I'm going to multiply and divide. So we got to do that division, and we got to do this multiplication. Okay, so we're going to do 5 minus, what's 16 divided by 4? It's going to be 4. And what's 9 times 2? 9 times 2 is going to be 18. Now, easy peasy, we just add from left to right. So 5 minus 4 is going to be 1. 1 plus 18, the answer is 19. Sweet, huh? You can do that, easy peasy. One last thing, powers of fractions. And here's a little stork, because that's where babies come, of course. Powers of fractions. So you can use exponents with fractions. Cool, huh? You can even use it with decimals. Of course, fraction is similar to a decimal, right? With fractions, they said it's really useful to do parentheses around the fraction. That way you know that this exponent means it applies to the whole fraction. It doesn't just apply to the numerator or to the denominator. So when you put an exponent of 3, what that really means is you're doing 1/2 times 1/2 times 1/2, because there are 3 1/2s. Just like if you put just a 2 here, it would be 2 times 2 times 2. If you put a 1/2 there, it's 1/2 times 1/2 times 1/2, right? And so you could just multiply that out. It would be, what would it be? All you have to do is multiply straight across when you're multiplying fractions. So the numerator is 1, and the denominator is 2 times 2, which is 4, times 2, which is 8. So that would be 1/8. Cool. Notice when you multiply by a half, you're actually getting smaller because you're cutting the thing in half every time. What about 0.1? Can you do 0.1 squared? Sure, why not? What would that mean? That would mean 0.1 times 0.1. And you could put that in your calculator, but it's basically a tenth, doing a tenth of it each time. So let's see what it is. Let's just put it, so 0.1 times 0.1. And it's actually 0.01, because this means a tenth, right? So it's kind of like multiplying this by a 10, which means moving the decimal one place. Cool. All right, last example, example 3. Look at this little boy. It's so funny. It's like he's confused by twins. He's like, okay, wait a minute. There's one over there, and then I see her over there. What's happening? Oh, what if Kayla had twins? Oh man, that would be crazy, huh? Okay, example 3 says to simplify this. So how would we simplify this? Let's do the math. Okay, so it's going to be 2/3 to the power of 2, which means 2/3. Well, I guess I don't need parentheses. You could just do 2/3 times 2/3. When you multiply fractions, of course, you just multiply them straight across. So the numerator times the numerator, it's going to be 2 times 2 is 4. 3 times 3 is 9. So it's going to be 4/9. That's the answer. Easy peasy. Alrighty, and guess what, Addy? Now it's time for you to go do your lesson, and you're going to have lots of fun, and now you're going to have babies on the brain. All right, love you, Addy. Bye.